Hello students, let us start the first chapter of the 12th standard syllabus, that is electric charges and fields. So the first chapter is electric charges and fields. Followed by the first chapter, immediately we have electric potential and capacitance. Electric potential and capacitance. These two chapters constitute electrostatics. Okay, what's the meaning of that? Let's try to understand the meaning of electrostatics. Electro, and then we have the word called as statics. Statics means charges at rest here. So whenever we are going to understand the behavior of charges who are not moving but they are localized, they are present at a given location, or we can say they are at rest, then the study of that nature of those charges, their interaction, everything comes under the chapter that is electrostatics. We can call it as a unit. Okay. Then what are the things that we are going to learn? Now we know there are two types of charges, that is positive charge and negative charge. Now every charge is going to have their own field, something like this. See, this is just a depiction. A depiction is something like a visualization, where once you have a visualization in your mind, there afterwards the next chapters when you study, it becomes very easy. So right now we are going to lay a foundation. So when we lay a foundation, it's not just about theory and formulas, but also we need to have a visual, like what are the things that we are going to imagine, right? You know that charges are something that we cannot see with our eyes. We can understand charges only by looking at the behavior surrounding the charges, right? For example, it is not possible for us to see gravitational force, but when I drop some object, I observe the observation here, correct? The observation that I see that object is falling towards makes me realize there is a gravitational force. Similarly, the behavior of these charges is something that makes us realize that okay, we can categorize charges as two things. One is this, one is that. This and this will attract, this and this is repelling. Correct? So this is the nature by which we classify plus and minus. Okay. Now, in electrostatics, what are the contributions a charge can give? What are the things that we can, for example, now when I say a charge, what are the things that comes to my mind? The first thing that comes to my mind is that a charge will have a field around it. Similarly, when I bring another charge nearby, such a way that the field of the second charge, when it interacts with the field of the first charge, this interaction may give us some observation. Correct? What is that observation? There can be a force between the two charges. That is observation. So, that is what we are going to learn. Forces between two charges. Then we'll upgrade ourselves to learn force between three charges, then four charges, and so on. Correct? We'll learn about the theory behind this. Then we will solve numericals and make sure that we are very much confident for the board exam. There afterwards we will push the numericals to Karnataka CET level, that is KCET level, and then we will push it further to the NEET level. Okay, alright. Now, this we will keep it aside, that is potential due to charges, because that belongs to the second chapter, as I said. Okay. The third chapter is current electricity. The third chapter is current electricity. Now you know current means the charges cannot be at rest. They need to move. So that doesn't come under electrostatics. So right now our focus is the first chapter and the second chapter. And without wasting time, let us go directly to the first chapter. Okay. Now, let's try to understand what is electric charges. As I said, electric charges is something that cannot be seen with our eyes. Correct? But still we need to define it. What is electric charge? So you are supposed to define something which you are unable to see. So, what is electric charge? The better way to tell, see, every book will have their own way of framing the sentences, giving a picture saying that this is the way I can define. Then there will be some other book which will tell that it can be defined this way. All of them are correct. Some books will give it short, some books will add more sentences to it. Okay, there's no big difference. Nevertheless, but something has to be present in all the definitions. That is, electric charge is an intrinsic property of a material. This is the sentence that has to be present. Electric charge is basically what? An intrinsic property of a material. What is the meaning of intrinsic property? If you find difficult to understand the word, it's basically a built-in property. Built-in property. Meaning, see, I can ask, why is me as a human need to have my eyes located over here? Why my nose has to be over here? See, this is my nature, the way I am. This is a built-in property. Same way, every particle or every matter that has born in this particular universe is going to have charges. That is an intrinsic property. That is a built-in property, or you can call it as a characteristic nature. Okay, you can use any of these words. Okay. So it's an intrinsic property of the material. That is one thing. Then further you can increase the definition by saying that this property, which property? This intrinsic property, whatever it is possessed by the charge, is influenced by electric forces and it is influenced by magnetic forces as well. Well, not directly, but indirectly. We will see that in the upcoming chapters when there is magnetism. Okay. So, in other words, electric charge is a built-in property of a material which can show us the behavior of electric forces. Let me move on. Okay. So, electric charges, here we have a definition as per the NCERT book. Now, some bodies gain charges by friction. Some bodies gain charges by friction. What is the meaning of friction? If you have one body in a very basic sense, if it is rubbed constantly over another object, correct? If the surface is supposed to be slightly rough, means practically it will be rough, then there is a friction that is generated. But if it is very smooth, then we term it as frictionless. But let us be very practical and call it as a regular objects. When they are rubbed against each other, there will happen to be some friction, due to which there can be some exchange of electrons between the body. Okay, alright. Then this is what we discussed just now. Bodies with the like charges repel each other. That is, plus and plus will repel each other. Then bodies with unlike charges will attract each other. See, this is basically a very general property which you have learned even in the previous grades, but I am going at little bit faster rate while speaking. Okay. So here you can see electric charge can be defined as fundamental property. Here it is given as fundamental property. You can call it as an intrinsic property also. Okay. Fundamental property of what? Basically everything. That is subatomic particles. Okay. That gives rise. This is very important. See, the definition is something where a huge paragraph of explanation can be compressed and formed sentences that are just sufficient enough. Okay. So therefore you have to understand every word in this. Once you understand this, then you will be able to write in your own words. Okay. That gives rise to the phenomenon of experiencing force. What force? Electric force, because we are talking about electric charge. In the presence of electric field and magnetic fields. These fields influence charged particles, resulting in observable effects. So I said the overall idea of understanding electric charge is the observational effects. Okay, alright. You have to practice this by writing. Recite the definition to yourself. Make sure you understand that 2 times, 3 times, 4 times. then write it something like maybe 3 times or so, correct? You know your own capacity, like by reading how many times or by writing how many times you feel that okay, I'm done, I have understood now. The moment you reach to that level, then only you move on to the next topic. Okay. Charges can be transferred from one body to another. Same way. When I said two bodies rubbed against each other, there is going to be exchange of charges. So generally that means it can be transferred from one body to another. Okay. This is just for information purpose. Then, if an object possesses an electric charge, it is said to be electrified or a charged body. This is a very common term to say. What is a charged body? A body that has charges. Okay. However, when it has no charge, it is said to be neutral. Now, when I say no charge, can a body have no charge? It is not possible, because just now I said that every body or something that has a mass, correct, they are going to have a charge. It's an intrinsic property. Then why I say that when it has no charge? So if a body is going to have a plus charge and the body is going to have a minus charge together, then what is the total sum of these charges? It is 0. So I can say it is no charge, but charges are present. So the better word for this is not just neutral, we call it as electrically neutral. Electrically neutral. This is the more better word. Okay, it justifies whatever you go on reading next. It should not contradict whatever we have spoken previously. Correct? It has to go always hand in hand. Okay. Okay, let's see about conductors and insulators. What do you see? So I have a ball over here. Let's say it is made up of some metal like gold or something. Okay. And what did I just do? So I brought a negative body, I made it in touch, and the negative charges distributed themselves. If you see, the charges were not just transferred from one body to another, but they were also distributed evenly. Why it is distributed evenly? That is because of the shape of the material. Okay, alright. So here you can see, when extra charge is given to a conductor, it instantaneously gets spread over the surface of the conductor. Okay. Now, what happens here? Now this is not a metal, this is a non-metal. Okay, this is a non-metal. Now what happens? Since it is a non-metal, there are no free electrons in them. Correct? When there are no free electrons, these electrons, whichever has been transferred from this body to that body, it is going to be a localized. Okay? So whenever you see any numerical, or anywhere you see any question where they say consider 3 or 4 local charges or localized charges, it means they are not going to move. Correct? It can also mean possibly that the object they are referring to in that numerical can be an insulator. Okay. Okay. How objects become positively charged? Basically, simple. The words are simple the way they are. How objects become positively charged, meaning I need to take first a uncharged body. What I need to take? I need to take an uncharged body. That's what it says. Correct? Then you make it positive or you make it negative. But first you take an uncharged body. But the question is, how do I make it positive? So I'm taking an uncharged body here. Correct? Then this whole body that you can see here, no matter what it is made up of atoms, and atoms are neutral. Okay. Because there is plus and minus. So together it is going to be a electrically neutral atom. Now, that's what they are saying. Positive and negative charges are equal. Now, what did just happen? So if you see here, from these negative charges, I am going to remove this charge. Okay, I am going to remove one negative charge. It's removed now from here. what has happened now? It is going to lack one electron. There is deficiency of electron, right? Basically, it is having less of minus. Minus means minus charges, meaning negative charges, because I removed it. So that makes it positive, okay, because it has lost negative. So a deficiency of a negative charge creates positive charged body, okay. So this is how you represent. Because I removed electron, it means only plus is present now, that way. The understanding is very conventional here. How objects become negatively charged? I think now it is self-explanatory based on what I just spoke. Again, take an uncharged body which is going to have again neutral atoms present in them. Then positive and negative charges are equal in that given body. It is not just one, this is just one atom, so there are infinite number of atoms. Then I added an electron here, as you can see, correct? So this gained minus, it gained a negative charge. So when you are gaining negative charge, you become negative, correct? So the overall body is now a negatively charged body. Okay. Let's see about gold leaf electroscope and grounding. So gold leaf electroscope is pretty important just for the sake of board exam. Okay, I'm talking about Karnataka state board. It's a simple apparatus used to detect charge on a body. So this statement itself is a multiple choice question. Okay. What is the use of a electroscope? Electroscope is an apparatus that is used to detect the charge on the body. Don't use any other word. Don't use words like it is used to create a charge. There's a big difference between creating a charge and detecting a charge. Detecting means finding out whether it is present or not. If it is present, yes. If it is not present, no. But it can't create its own charge. Okay. So the word is very important here. Okay. Let's see what all things we have. So we have an enclosure here, a closed system with a glass window so that we can see what is happening inside. Then we have a metal knob on the top. We have a metal rod. That means I have a conductor and a conductor. Then I have an insulator. Then I have gold leaf. Leaf is just is not exactly meaning leaf. You can just call it as a thread or something like that. So these two threads, as you can see, or it can be a plate like structure like this. Okay. It can be two plates. It's basically a three-dimensional figure. We are trying to show it in a two-dimensional figure. Okay. So, anyways, there are two gold conductors, right? Like this. They are in contact at one end, but not contact at the other end. Okay. Principles like, yeah, that is okay, fine, no problem. So let's see what happens here. So I'm bringing a negative charge body near it. It will acquire negative charge and the charges will flow, correct? Because it's a conductor entirely. What will happen? What does light charges do? They repel. So this is what happens. Okay. Similarly, if I bring a positive charge body, what will happen here? Same thing. The positive charges will flow. Then the positive two ends will repel. Correct? Okay. So what did we detect right now? We detect that the gold electroscope now possesses like charges. Now I bring a negative plus charge. Now I make it a electrically neutral. Okay. Earlier it had additional of, it had minus. Then what I did, I bring in plus. What happens? It's just for observation. Okay. Whatever I'm telling you, it becomes electrically neutral. Now from previous state, now the previous state was somewhere like this, right? Now it is converged. Earlier it was diverged. Now it is converged. So again, these two words are important as far as MCQ is considered. Okay. Now there will be some topics which will be deleted from syllabus, again put back, again removed. At the end of the day, knowing is better. Okay. Once you have known, there is no purpose to study every day. It's not required. Once you have understood that this is what it is, and if you're able to remember it, enough. Okay. Whether it's deleted or not, whether it's there in the syllabus, we'll keep it for the. We will think about it when the exam comes. Now it's not required. Okay. Let's move on. The same thing. I'll just skip that. Okay. Grounding. What's the meaning of grounding now? See, every house or every building that is constructed need to have a perfect grounding. Means if there are any additional charges inside a household, it has to go to the ground. When I say ground, we literally mean the ground. It is not a label term, like it's not just a term that has some other meaning. Ground means ground. It's a floor. Okay. Floor means again the floor of the earth, not the house. The process of sharing the charges with the earth is called grounding, or the other word called as earthing. So you can use either of these words. What is that? You can use the word called as grounding, or you can use the word called as earthing. This is the symbol for grounding. Now where are you going to look at this symbol? Not now. In the part B chapter, perhaps. Again, in current electricity also you may come across this symbol. This symbol is for ground. Okay. So I have a body here right now. Let us see what it is. What is it? I have a body, as you can see. Is it a metal or non-metal? What do you say? Are the charges evenly distributed? That means there has to be some free charges. That's why the charges are able to move. So this is going to be a metal. So by default, it was a positive charged body. Correct? When I consider it. When I ground it, what happens? All these plus charges, what happens to it? They all go to the ground. Okay. That is we can call it as excess charge, or you can just call it as a positive charge. As long as it is connected to the ground, correct, then all the charges will flow to the ground. Okay. The same thing. It came 2 times. Okay. That's understood. Just now, if you see what has happened, what happened here? See, the minus charges have come back here. What does it mean? Me giving plus to somebody else is same as saying me receiving a negative. Correct? If I am giving plus, that means I have become a negative charge body. Just now what we discussed. Or if I give a minus, I call myself as plus. Okay. So in other words, just like saying the plus has gone down, it is same like saying minus has come up. Okay. Now you must have seen this socket in your house, right? Where you have, if you are using a laptop, you know you will use 3 pins, and maybe for mobile phones you use 2 pins, right? Okay. So in that, one is known as phase, the other one is known as the neutral, and the main one is known as ground. Okay. The one at the top is always ground. See, this is a metal rod, as you can see here. It is connected to some building over there. Okay, so all the excess charges will flow through wire, through the rod and down to the ground, especially during rainy season, during lightning. These are going to be more useful. Okay. Okay. Charging by conduction and charging by induction. I think you must be knowing these terms by now already. What is the meaning of conduction? When 2 objects are in contact with each other. What is the meaning of induction? When the 2 bodies are not in contact with each other, but I bring them near to each other. Okay. We can call the best word is vicinity. One object is in the vicinity of another. Let me write it here. VICINITY. Let us see. Charging an uncharged object. Again, same thing. I'm going to take a 1 second. I'm going to take a uncharged object. What is the goal? I'm taking an uncharged object and charging. So I need to charge it. So either you make it positive or you make it negative. It doesn't matter. But you charge it. Okay. Alright. So what is the first step? First step is consider a conductor A who is having already positive charges. Then you consider a uncharged conductor, that is B. What do you expect? Let A and B be brought into contact because it is conduction. For conduction, you have to bring the objects in contact with each other. Okay. So I bring in contact with each other. What do you expect? Let me just use all the slides. We can see the positive charge, the transfer of charge from one body to another happens. Yes. How long it will happen? Will it keep on happening forever? No. There is a particular point up to which it can happen till both of them have equal charges. It should be a balance. Right now it is unbalanced. How? This is having zero charges, this is having plus charges. This is not balanced. Okay. So you have to balance the imbalance here, and therefore let me use all the animation here. Okay. Right now we have 1, 2, 3, 4, 1, 2, 3, 4. Equal positive charges in both the sides. Now I can take them apart. What will happen? So earlier it was uncharged, now it is charged. Okay. See, I know the words are very simple to explain. I just use certain animation so that you keep a visualization in your mind. There afterwards, when we solve numericals, whenever I say consider a charged body, a positive charged body, these are some of the pictures that has to come to your mind. Okay. Alright. Okay. When A and B are taken away from each other, A and B both will have positive charges on them. That's the conclusion. Alright. So in this method, charges are transferred due to contact between A and B. Right? Okay. Then charging an uncharged body by induction. Again, I'll go a little faster. It's quite simple. Consider an initially uncharged conductor A. Now I have A as a, what is that? Uncharged body. I brought B, but you see I have not touched them. I just brought it in the vicinity of A. Yeah, what happens? See, let me bring it back again. See, the moment I bring minus charge near to the uncharged body, uncharged means what? It is having equal number of plus and minus, right? So the plus will be attracted towards minus. So that is why you have all the way here plus charges and the negative charges are on the other side. More importantly, you see the number of charges 1, 2, 3, 4, and this is 1, 2, 3, 4, equal number. Still it is a neutral object. Okay, just because I have drawn charges, I cannot decide whether it is positive or negative because they are equal in number. However, what I can say is that the distribution has been changed now. It has been altered. Earlier it was in random directions. The spread out of plus and minus charges were very random, but now they are very specific. Okay, why? Because the minus is telling the plus to be oriented this side. By default, the minus will go that side. Okay, so the positive, once again, the positive and negative charges of A reduced. Okay, that is fine. Alright, now what I will do, I will ground. See the symbol of ground. If you see here, the minus is still holding this plus, but nobody is holding the minus. So eventually the minus will go to the ground. Okay, the minus will go to the ground. Now you can remove the ground and you can remove this. What will happen? Now they redistribute themselves evenly. So earlier A was an uncharged body, right? It was an uncharged, no charges at all, means electrically neutral. Now the plus were there on one side, then I removed the one that was holding it, I removed that object. So now it will redistribute itself, and the ground also is removed. Okay. Then charging is the same thing. Now I am going to do it with the plus. It is still not in contact. Earlier I made the body as positive charge body just now. Now I am going to make it as a negative charge body. The process is same. So I'll just skip the part. Okay. You can see just the animation over here. So plus is brought near to this object. So minus will be attracted here. Plus will remain far. You ground the plus and minus will remain. Let me go to the final. Let me just slow it down. Okay. Alright. So now we will see charging two uncharged objects by induction. So just now I charged only one object at a time. I first took a charge is to be positive. Then I went to the second case, again uncharged, and made it positive. But now I am going to take two objects who are electrically neutral. Okay, let's charge these two, but we are not touching them because it is still by induction. The question is about induction. Okay, I brought them. I think the animation just missed a little bit, but they are not good. They are not supposed to touch. Okay, they are not supposed to touch. Okay, perfect. Alright, so I am bringing a negatively charged body close to two objects who are uncharged. What happens? See here, minus will attract plus. So by default, what will happen? Minus will be over here. Correct? Okay. Now because minus is here, what attracts minus? See, these two are in contact. This part over here, they are in contact with each other. Contact with each other means they will charge each other by conduction. By conduction. Okay. So let me just use the slides completely. Minus is there, so this will become plus. Minus attracts plus, and the minus will go to the other side. Okay. I hope this is clear. Now I'll bring them far. One of them I'll keep it far. Remember what were the charges here I told? There was minus here and there was plus here. Okay, I'll bring them far. Let me see what I'll do next. Okay. Let me just erase this part here. Okay. Because the signs are overlapping, I don't want any confusion to be there while I'm explaining. Okay. So now what happens? I remove the object far, then you have to ground it like usual, same process. I've skipped several parts here, and this becomes a negatively charged body and this becomes a positively charged body. Okay. Alright, let's see what is next. Properties of charges. Now let us see what are the properties of charges. I think I'm sweating.